How's it going, everyone? First of all, thank you for coming. I really appreciate it. So first, I'm going to start with a little bit of story. Approximately 2,500 years ago, in a place called Pelusium, there was a battle between the Persians and the Egyptians, after which there were a sea of skulls assembled on the ground. And an old historian named Herodotus came to the site to review it. He was a Greek historian, and he found that the skulls of the Persians would crack with the touch of a small pebble, but the skulls of the Egyptians were absolutely unbreakable. And upon considering the reason for this, he concluded that it was likely the fact that the Egyptians would shave their heads from a young age so that sunlight would be able to touch them, whereas the Persians would cover themselves very much with cloth and so on. So my name is Maruca. I'm from Philadelphia. I'm 20 years old, and the reason I'm talking here today is because I have some information I've learned about that I think would be of interest to anyone who's interested in optimizing their health from a fundamental level. Because when I was about 14 years old, I was having some issues where I didn't feel well, and it just wasn't really going well for me. I was going into high school, and I thought that my life is mine for the taking, but I wasn't feeling well. And I think that's sort of the thing that many people in this community are dealing with, or were dealing with. There was something that was keeping you from living the life that you really wanted to live, and so you decided to make a change. And that's sort of what I did, and this is sort of the progression of my journey. So just like me, there's 1 in 2 people today have a modern chronic disease, it's called. So again, one of these 2 people is likely to have at some point in their life a chronic disease, whether it's obesity, diabetes, heart disease, anxiety and depression, cancer, autoimmunity, and so on. And this is in the United States in specific, but it's a general issue in the industrialized world. And even a report done with the Congress of State Legislatures in the United States showed that out of the deaths that occur every year, approximately 3 million in the United States, 2/3 of them are due to chronic diseases, which even they acknowledged are largely preventable. So the motivator for me is the fact that there's all these people suffering from chronic diseases, and I was suffering from maybe early stages. I was feeling daily having headaches. I was having gut issues. Every time I would eat, I would have some bloating, gas, and all these things. And I was also having allergies, and these are things that I never thought could be improved. But then I tried a diet that was aimed to improve my skin, the sort of ancestral paleo diets, and miraculously, these other issues that I thought were genetic and incurable actually started to fade away, but it wasn't quite enough to put everything aside for me, so I started looking deeper, and this is kind of how I ended up where I'm at. So the issue that happened for me was that I was trying to fix all the issues I was having with a food approach. I was trying to essentially cure the diseases I was having by healing my gut with healthier foods and so on. The issue was that it wasn't working. So the thing is, today, not today, but in the modern world today, and a few days ago, I was listening to a podcast by a couple of leaders in the, let's say, health community. And basically what they were saying, the content of their discussion in the beginning was modern diets are the answer to solving the diseases that we're facing. And they said specifically, food is the #1 lever to improve chronic disease. Of all the things that are out there, food is the #1 lever. And they said you won't find any disagreement upon that in this community. And I'm here to actually share that this is something I would disagree with. And not because it's not well-intentioned, but because there's research showing that there's a bit of a deeper level to the matter that I would like everyone who's listening to this to be aware of. So, in order to move forward, it would be beneficial for us to define what is health, because I believe that in order to understand chronic disease, the best way to do it would be to look at a more fundamental level of living organisms and to understand how they actually work so that we can look and see why is there a problem. For example, if your cell phone was broken, or something wasn't working, you didn't know what it was, and you went to a couple, let's say, people you thought might be able to help you, and they all just said, well, I don't know what's wrong, so probably your phone can't be fixed. You might say, if you're curious and interested, you might say, well, maybe it's not that the phone actually can't be fixed, it's just that these people don't understand what's going on inside of it well enough to be able to come to a solution. And that's essentially why I think health needs to be defined. So To me, health is the ability of an organism to carry out its functions properly. The more standard definition is a state of well-being, which I believe is brought about by the organism carrying out its functions properly. So a living organism then also ought to be defined. What is a living organism? What is life? How does it work? Because if we don't understand that, how are we going to understand what it means for it to be working well, if we don't understand what working means at all? So to do this, it would be helpful to look back at where life began to understand what we have in common and maybe have an idea of where life, how it functionally works. And so this is a picture of what's called an alkaline hydrothermal vent at the bottom of the ocean. And essentially what's happening in this is that there's a lot of seawater, and then there's a lot of these alkaline fluids coming up from under the earth that are heated by the strong infrared light and energized in this way from the light in the earth. So actually the first living organisms, they weren't using sunlight, they were primarily based on energy coming from infrared light. And so the flows of this basically fluid contrasted with the flow of ocean water created what's called a proton gradient. It's basically an energy source where there's more what's called protons on one side of a surface and fewer on another, meaning that they want to go from where there's more of them to where there's less of them. And that's basically an energy source. It's kind of like if you guys were all trapped in this room and there was no one in that room and you couldn't breathe and you were stuffy, you'd want to go through there. But instead of just flowing through that door into the empty room next door freely, what life essentially does is puts a revolving door that's basically electric. So when you go through, you spin the revolving door and you generate energy. That's basically how life began and how life works. Eventually these cells, which were sustained just by this naturally occurring proton gradient, exited these alkaline hydrothermal vents, and what they did after having the initial spark of life coming from the naturally occurring proton gradient, life went on to become what I would call an investor. Essentially, what life is looking for, at least from a chemical perspective, is where there are two molecules called a redox couple, molecules that would like to react and they would be satisfied and that would release energy if they react, but they're configured in such a way at the moment that they aren't actually coming together. They're held by something else. So a great example for this is fire. If you have fire, for example, you have oxygen here in the air, and then you have a substance like wood present here, leaves, anything like this. That's a hydrogen-based fuel source. Anything coming from life is hydrogen-based. So basically, there's energy in the bonds between these molecules in that wood, in that fuel source, and if they're broken, and then the hydrogen bonds with the oxygen in the air, it releases a lot of energy, and that is what creates fire. So you put a spark, right? And the spark starts the reaction. And then every time that the hydrogens react with the oxygen going forward, it releases more energy to continue to break the hydrogens free and continue the reaction. So this was the spark, and then the cells broke free and went on to begin to catalyze all other sorts of molecules around the planet in order to basically generate a living. So it's like an investor. There's an opportunity, you put in a little bit of funding, and it allows it to go even further. And that's actually what life does. And I'll explain like how we do it, at least at our cellular level. So again, the way this was happening, I already explained it with the hydrogen and the proton gradients. This is what our mitochondria, our cellular engine, looks like. But essentially, at the time, life was constrained. What this means is that there was only archaea and bacteria. So do people know what archaea and bacteria are? Yeah, hands, anyone? Great. Archaea and bacteria are the primitive life forms that existed for the first 2 billion years of evolution, approximately. And so what life is doing at these times is basically generating energy across membranes with these gradients. So what happens is if the cell gets to a certain size, there's a ratio of membrane around the cell which it can use to generate energy. And if it gets too big, there's more volume than can be supported by the energy that is being generated by the membrane that's there. So basically, life couldn't get larger than a certain point, and that's why bacteria that are living everywhere were never able to expand. The cool thing about understanding us and how we work is looking at how did we get past that constraint to something that's literally billions and trillions of times larger than the first organisms that were alive, the archaea and bacteria, for the first large chunk of all of evolution. So I believe it was more like 2.5 billion years, it was just them, and then 1.5 billion years ago, there was a merger, which is how things happen. So essentially, two old organisms, one being called an oxidative cyanobacteria, one called an archaeobacteria, they basically made a deal. One would be the master, and others would be the slaves, and essentially, but in a way that they were both actually interested in. So essentially, the master, which is the nucleus cytosol today in our cells, it was a bacteria that was focused on structure, anatomy, carrying out the genes. So these organisms, they all had lots of genes, these mitochondria, which took all of their energy basically to maintain. And so life was constrained in this way. But what happened was they gave all their genes away to one master host, essentially. So that now all of these mitochondria, they're spending, or these archaeobacteria, or oxidative cyanobacteria, pardon me, they were no longer basically holding all of their genes. They all gave it away to sort of their master. And so they didn't have to think about how to handle their structure and so on in general. What they mostly had to focus on now was to generate energy. So now you have one big boss who controls structure and function, essentially, and one that basically controls energy. And so what that means for us is that it allowed us to basically start to expand, because now you have, instead of 1,000 or hundreds of these organisms generating energy for themselves and maintaining all their processes, they're spending it all just on maintaining the cost of a genome. Now 90% of their genes have been cut, and so they have all of this spare energy that's just not being used for anything, because again, they gave away 90% of their genes. And you can fit now dozens and dozens, we actually have hundreds or up to 1,000 of these mitochondria in our cells. So essentially, by going from having each of them individually to maintain themselves to essentially one focusing on all the energy costs regarding the genome and the rest focusing on generating that energy, life had a massive surplus, which allowed us to become more complex and expand. That's basically this basic way of explaining it. It's complicated, but I'm hoping it's getting clear. So essentially, these cells came together, and the way that these mitochondria, these cellular engines in us that power our cells, work is by the same mechanisms that the initial living organisms work. So to provide a little more context, a good way to explain this is that me, you, we are dependent on these tiny little engines called mitochondria, which initially merged with another type of cell, becoming, you could say, the slaves, and just generating energy. And that amount of the energy they provide allowed us to get massively complex. And so mitochondria are in every single one of our cells. They power all of our functions. For example, the reason we breathe is because mitochondria use oxygen to generate energy. So if one has doubts about, this is even the researcher who's taught me a lot of these things, he makes the joke, if someone has doubts about the importance of these mitochondria in our bodily functions, just try to stop breathing for 5 or so minutes and see how you fare. And that will provide you with some perspective on just how relevant these are for us. Or for a quicker experiment, I'm not suggesting one does this, but there's a poison that was used when prisoners would be captured called cyanide. People familiar with cyanide? It kills you instantly. And the reason it kills you is because it collapses the proton gradient. So there's protons again on one side, they want to go down, and we control their flow down to capture energy from that. Again, and I'll explain this, but basically this eliminates that gradient, and so all the energy basically dissipates, and you can't spark it back once it's pretty much done. I mean, to some extent, yes, but once an organism is fully dead, you can't bring it back. So the way that our cellular engines work, to keep it basic, we take food, we break it down in a process called glycolysis, and then we transport the breakdown process of that. I believe it's called pyruvate. I'm not the specific expert on the mitochondrial inners, but basically, pyruvate is transported into this citric acid cycle, which would break down the food further into something that we can actually use, which is basically hydrogen. Like I was saying, we're a lot like a fire, because hydrogen is the fuel source in a fire, and we also use hydrogen, and we react it with oxygen just like a fire, but it's more controlled. We do it more slowly, you could say, but there's a lot of energy in us keeping us moving. So we donate the hydrogens to this chain called the electron transport chain. And what this essentially does, the hydrogen donates its electrons, and then the electrons are funneled across a series of these proteins, and each time the electrons are funneled, the proteins basically take a bit of their energy and use that to pump hydrogens from this place where the hydrogens are into this place where there's more of them. And so again, then they want to flow back down, and so we put them through something called the ATP synthase, which is what generates the energy, or ATP, that we use to carry out a lot of our reactions. So if this process doesn't work optimally, then we're going to have problems. And yeah, this is the basics of mitochondrial function, essentially. So we want this to work really well, because if this works really well, we have a lot of energy. Does anyone here drink coffee in the morning? Yeah, a lot of people do, because coffee improves the function, or temporarily improves the function of mitochondria. Same with nicotine. These kinds of things, they improve mitochondrial function briefly, but it's not necessarily like just a good thing, because there's sort of more of a long-term cost. Methylene blue is another substance a lot of people are using. They make their tongues blue, but people are walking around with it. It's pretty interesting. So anyhow, that's mitochondria. So this is a guy I've learned a lot from. His name's Dr. Douglas Wallace from Philadelphia, my hometown. What he's basically shown is that when this process in our mitochondria breaks down, he started studying rare mitochondrial diseases, right? What he found was that in the modern chronic diseases that we're facing today, in general, there's a dysfunction in the mitochondria. It isn't just in the rare mitochondrial diseases he was studying. He's also the guy who, his lab mapped the migration of mitochondria from Africa. So we only inherit mitochondria from our mothers, because if the genes mixed, the mitochondrial genes, they still retain a very small amount of genes directly related to the process of energy generation. Sort of like if you had a power plant, the mayor's office of the town might have the blueprint for the power plant, but the wiring diagram, how it works in case of emergency, is kept at the power plant, of course, because it can respond more quickly to issues in these cases. So what he's shown is that, well, actually, so he showed the migration, because when we move, when something is passed down from the mom alone and it's not mixed every generation, they can more effectively track the movement. So the map people can imagine from Africa, and then there's people branching out, moving into Asia, into North America. You can probably imagine this. Could have it here, I should. But anyhow, they were responsible for developing that map accurately and confirming its existence because of mitochondrial genetics that are passed down from our moms. It also means that if our moms have issues in their energy generation processes, we're apt to receive these and have problems as well. But essentially what they found is that, he says here, the genetic perspective has failed to explain the modern chronic diseases. It might be that it has more to do with energy generation and mitochondrial dysfunction, which sure enough is what they've seen in their research. So for example, if you have issues, and so you have dysfunction in oxidative phosphorylation, that's what OXPHOS is, which is that process that I showed with everything, the electrons jumping and then generating energy. So if you have dysfunction, there's more free radical generation and problems. There's damage in the mitochondrial DNA due to this, which it could be posited very well that is a natural way to attempt to look for a solution. For example, when people move to the tops of mountains like the Himalayas, a lot less oxygen present to use our oxygen-burning fuel engines. And so there's going to be an issue, but that leads to acute mutation of the mitochondrial genes. And keeping in mind, there's hundreds and hundreds of these in every single cell. Cell has one nucleus of genes, but hundreds of mitochondria with their 13 genes. And so they can change a lot faster. Even a cell doesn't live that long. Mitochondria live even shorter, but they cycle quite a lot. And so we can come up with rapid adaptations in energy generation just by mitochondrial mutation. So one could posit that the dysfunctions we're seeing today are actually attempts by our body to attempt to find a solution, and we're mutating the function of our mitochondrial genes in order to do so as a result of decreasing our energy, let's say, absorption and function from the environment, which we'll get into. But essentially, if you have this issue in certain parts of the body, like in the brain, one's more likely to have something like depression, or if it's from a mother passed to a child, autism in the born child, or childhood obesity. For example, if there's issues in the metabolism, diabetes, obesity, inflammation, there's type 1 diabetes, other autoimmune diseases as well. It's pretty comprehensive, it's fascinating. So the modern diseases that we're facing, which 98% of the US budget, at least, is being spent on researching the nuclear genome, is actually caused by mitochondrial dysfunction and mitochondrial genome defects, essentially. So it's kind of a mess, is what he explained to me. I had the very great fortune of being able to meet and speak with him. And this you can't see very well, but his team gave it to him after he won a fairly prestigious award called the Franklin Award in the United States for his research. And it's him flying it's like Benjamin Franklin, who discovered electricity with flying, or sort of discovered flying a kite with a key on it, and it was struck by lightning. He's flying a mitochondria kite, and so it was like sort of a symbolic, because he's really a visionary as far as modern disease goes and deserves a lot of attention. So here's the cool thing. Our engines in our body aren't just like fire, like a controlled fire. It's a lot like a car. So in a car, you have all these pieces of the engine in particular, but let's just say in these dysfunctions, what's going on essentially is dysfunction in the spark plugs of the car. So what these do is they signal for the spark that ignites gas and pumps the pistons and makes the engine go. So essentially, that's what's sort of happening in our mitochondria. They're not working optimally. The structure and the pieces that allow us to generate energy and move those little pieces along aren't working optimally. Now, here's the question that I have for you guys, for someone in particular. What would happen if you had this engine and the spark plugs are worn out, and then you tried to put in premium gas to fix an issue that lies in the broken spark plugs? Maybe because you have a lack of understanding, one has a lack of understanding about the engines and how they're working. So what would happen is the spark plugs, as you might imagine, wouldn't get better. They wouldn't just be fixed. The engine would continue to have problems. And in a car's engine, this looks like, for example, failing to start properly or not being able to accelerate and things like this. Anyone who knows about engines, I hope you can appreciate this even more, or appreciate maybe the inaccuracies, but see where the idea is there. But essentially, it's pretty solid because the car has an ignition system which is independent of the fuel that's going in to the engine. So the point is, trying to fix a broken engine and where the problem isn't about the fuel, but it's in the spark plugs, won't work. So premium gas won't fix it, and I'll just say this now, but healthy food is what I'm referring to as premium gas, but you'll get this in a second. And fuel additives, for example, something like vitamins, also won't fix the broken engines if the problem's caused by old faulty spark plugs. So, and our engines, again, they're a lot like a car. In fact, cars also burn hydrogen-based fuel, really easy to ignite because it's in the form of something like refined petroleum, so gasoline, jet fuel also, very easy to burn, releases a lot of energy. And so we react that with oxygen, that releases energy, and we use it to do work. So the question then, of course, what controls the human's ignition system? And the answer is, it's not food, the fuel that's going into the engines that control our body and allowed us to become complex and power our function and our life. Remember, if we stop breathing, we die very quickly. And if they don't work well, not that they fall apart completely, but if they don't work optimally, then we have diseases, dysfunction. So what's controlling the ignition system of the mitochondria? And it's light, not food. So that is what I came to after lots of research, trying to essentially refine the gasoline going into my body, into the cellular engines, powering my body, which again, functioning well, I'm healthy. Not functioning well, generally very likely to have some sort of chronic disease, which I did. I had several issues. Headaches, this kinds of things are linked to mitochondrial dysfunction as well. Some of those things were even on that slide with the diseases. Anyhow, so, because I was going from, for example, the paleo diet to the autoimmune protocol. Anyone familiar with autoimmune paleo diets? It's when you remove anything that's allergenic from your diet to stop triggering this reaction of inflammation in the body. But the question is never asked, at least from what I read, why is this happening in the first place? Why is the body reacting so much to food? Same in the carnivore diet communities today where, and again, I think they're doing a lot of great stuff. People, focus on just eating meat, removing all plants that can trigger issues in the body. But the question no one's asking, they're saying plants are generally bad for humans, so we should avoid them entirely. And I wouldn't necessarily disagree that plants aren't the optimal food source. However, the fact is that for a long time, people have eaten grains, which are not allowed on paleo diets. We've eaten sugar, we've eaten lots of things. sugar maybe not as much, but grains and vegetables and these kinds of things, and have enjoyed optimal health. Only in the last more recent decades have these modern chronic diseases began to skyrocket. So it would imply that it isn't plants and grains that are causing these modern diseases, which again, they didn't exist and skyrocket when we started eating grains 10,000 years ago. They only started skyrocketing in the last 100, 130 years. What happened in that period? There was a big change in food. It's gotten a lot worse and more refined, but it doesn't quite explain the issue from the fundamental level, and it definitely doesn't explain nor why it's happening, nor how it can be solved. So, how does light control our ignition system? Well, one way is directly. The action of red light on mitochondria. Many people have probably heard about this from companies like Juve, Red Light Man. There's some exhibiting here sharing red lights. They know that it improves mitochondrial function just by having red light and infrared light exposure. It increases the production of ATP and basically makes our mitochondria work better. And this is light that's present in the sun constantly. We're designed to be exposed to generally throughout the day. Maybe not in direct sunlight. Even if we're in the shade, we're being exposed to the full spectrum of this light, and it's tremendously beneficial in one way directly. Also, light controls a lot of other processes in our body, including our circadian rhythm, which is this ongoing approximately 24-hour cycle. That's what circadian means. Circa in Latin means approximately or near. Dies means day. So circadian means about a day, because when they first observed it, they were like, it's about a day. And it kind of makes sense that it's synced to the sun, because there are certain processes that need to be controlled as the energy is fluctuating on the Earth within a given day, day and night, the classic sort of yin and yang example. So sunlight's controlling this process of our circadian rhythm, and for example, the creation and production of certain hormones, vitamin D, melatonin. You feel happy in the sun. There's an effect of sunlight on serotonin and these kinds of things. Melatonin's actually been shown to be very beneficial for mitochondria. It's taken up by the mitochondria, acts as a powerful antioxidant. So basically what I'm getting at is that one of the things that, again, the way this controls the ignition system of our mitochondria is because we're designed naturally for this master, amazing anti-aging, antioxidant hormone, melatonin, to repair these cellular engines, to repair their function each night when we sleep, if we're living in congruence with the natural cycles for which these processes evolved. But we're not. And then this is 3 slides from Dr. Wunsch, who's in the back of the room, a very great teacher and inspiration of mine, and basically showing, this one is showing that a molecule called benzene in a lot of amino acids that we consume is sort of a photon trap. It can absorb ultraviolet light frequencies. And even here, there's a chart that shows that these amino acids, which are precursors to a lot of key molecules in our body, also are designed to absorb ultraviolet light frequencies. So this is one of the other ways that sunlight controls a lot of the processes going on in our body. So it's indirect, but it has a tremendous impact. And there's research that's been done throughout the last 100 years by very advanced researchers, which we don't hear about very often. But they saw the effects of sunlight just through the eye. It affects everything because the hypothalamus, which is this master regulatory center in our body, controls the function of a lot of different glands, which again secrete a ton of different hormones. So ultimately, just light coming through the eye affects non-visual, meaning pathways that aren't related to vision, but energetic pathways that relate to our bodily cycles and so on, the production of key hormones and everything. So again, this includes things like histamine, serotonin, melatonin, sleep, and good mood, and so on. Dopamine from tyrosine, which is related also to trend recognition and feeling well and things like this. There's a lot more. It's also linked to our sex steroid hormones because cholesterol is broken down, just like it turns into vitamin D3 eventually. Also, this precursor cholesterol becomes, for example, progesterone, testosterone, estrogen, and so on. So sun controls a lot of processes in our body that we're just completely unaware of. And being unaware of it because it's not visual, we don't directly see it, we're not considering the impacts of living an indoor lifestyle. We're considering artificial light to be a mechanical thing where we can see and it helps us to see and that's it. But we're just not aware in general of the tremendous amount of research that's been done on this subject. And I did a podcast with a guy named Ben Greenfield that's going to be launched on the 21st of September, where I actually go through for an hour and 45 minutes and lay out through all this research throughout the last decades. Too much time for this talk, but if you're interested, there's a lot there. So it's really, really interesting. Artificial light, on the contrary, has tremendous negative effects on these systems, directly and indirectly. So for example, this is the spectral composition of sun around midday, lots of the whole spectrum. And then this is an LED, big spike in the blue range, which happens to be the range that affects our circadian rhythm and our biology the most. Incandescents have less blue light, which is great, but they're missing ultraviolet. And even the low amount of blue, if you're living under it constantly, you're not getting the fluctuation for which we're designed to be obtaining. Fluorescent bulbs, forget about it. There's massive spikes. They flicker. Everything that's mostly plugged into the electric grid, not everything, a lot of it has a flicker effect that affects the body negatively. So that we can't consciously perceive. Essentially, so yeah, blue light frequencies from these artificial light bulbs coming in disrupts our natural secretion of melatonin, disrupts the circadian rhythm, which is the way we're designed to be operating, just by being exposed to artificial light at night, the blue frequencies in particular. It creates problems in our secretion of key hormones, our sleep and wake cycle, and so on. And also directly, blue light, it increases the production of reactive oxygen species, again, which are these inflammatory molecules, essentially, that are linked to mitochondrial DNA mutations. Not very great. So anyway, these are some of the negative effects of blue light exposure on our body. And this is the light that we've begun to live under. So this is just a chart of the melatonin suppression of different lights. Fire is the lowest. So a great question when it comes to sunlight, everyone always is asking, is does sunlight cause skin cancer? And so I would ask the question, again, it's not black or white for sure, but if sunlight caused skin cancer, what would we expect to happen to skin cancer rates upon the transition to an indoor lifestyle, which is how we currently live today? And presumably we would expect them to drop, but that's not the case. Skin cancer rates have skyrocketed in the last 100 years since we transitioned to an indoor lifestyle. Interesting, right? Also, would we expect the rates of skin cancer to be higher, again, percentages, not an absolute amount, to be higher in people who work outdoors in the sun or indoors? And naturally, we would theoretically expect it to be higher in those who are working outdoors. But studies have shown, one in particular, that was from the 80s, so the controls weren't necessarily as good, but the results were statistically significant. Workers indoors under fluorescent lights have higher rates of skin cancer than those working outdoors. Interesting. So maybe it's not black or white, the sun causes skin cancer. I would say it has a lot more to do with the transition to our indoor lifestyle. We no longer get the natural adaptation, so we go out, we get fried, and this not only will cause problems in the physical appearance, but it also will cause potentially, these risk factors that lead to the skin cancers that have been researched. Another reason why sunlight doesn't cause skin cancer, or at least would imply that it doesn't, is that there's a guy named Alexander Gurwitch, who is an old researcher who discovered something called biophotons, which are these little particles of light emitted by living cells. So our bodies, we're essentially beings of light. Our cells use light to communicate. They found, for example, our fingertips emit more biophotons than anywhere else on our body. It's sort of like Qigong masters in the ancient Chinese practice of Qi. They are aware that our fingertips typically emit more Qi than anywhere else. It's very likely a similar phenomenon, if not the same thing. So one of the things that he and his predecessors found is that our cells communicate with ultraviolet light, extremely low frequency ultraviolet light, which basically, for example, the stimulus he found for mitosis, cell division, is ultraviolet light emission from cells. So if UV light from the sun was all bad and caused skin cancer, we probably wouldn't use it to signal for the cell division that's happening billions of times in our body every day. Just a consideration. There's this too. Sunlight was found when everyone in the Industrial Revolution, it was up to 90% of children in England, here in London, there was high rates, 90% of children had rickets in London in the Industrial Revolution, approximately some form of rickets. And what did they find? They found that the cure was UV sunlight exposure, ultraviolet light from the sun, because it helps us to synthesize vitamin D so we can properly absorb calcium. People generally know about this today, and that cured rickets from children. And they did this in clinics in the Alps, exposing people to sunlight. Heliotherapy, it's called. Also, this is a picture of someone with lupus vulgaris, which is tuberculosis of the skin. Just exposure to ultraviolet light from the sun, which kills the bacteria responsible for this, cured this. And the researcher from Denmark won the 1903 Nobel Prize in Medicine for this because it was a pretty big discovery. This was killing people, and you just have to be in the sun, and it basically solved it. I mean, not just any sun, it's targeted exposure over quite a period of time, but it's very fascinating nonetheless. So the implications of this, what are they? Well, first and foremost, this is already clear, attempting to fix fundamental problems in our cells, particularly the diseases which are caused by dysfunction of our cellular engines, the mitochondria, with fuel additives, aka vitamins, or higher quality fuel, aka food, or other sorts of interventions like drugs, isn't going to work because it isn't addressing the fundamental issue, which is, in my opinion, the transition to an indoor lifestyle, massive exposure to artificial light, disruption chronically of our sleep cycle, circadian rhythm, and so on, and a complete absence of the sunlight, which drives a tremendous amount of processes in the body, including, again, the synthesis of key hormones, mitochondrial optimal function, sleep and regeneration and repair, which keeps us young and healthier, and so on. And so that's essentially, I don't have time to go into what is the solution, but again, there's plenty of resources I put out online people can look into, or podcasts specifically I've done about what I call the light diet. So it's a diet of light, so it's a diet focused on not the fuel going into our engines, like the car engine, remember, but focused on fixing the ignition system, which is those spark plugs, which the problems of which are not caused by the food. Again, if you eat terrible food all the time, you'll also affect the engines negatively. It doesn't mean eat bad food. You'll clog it, you'll create all kinds of problems. But the issues we're facing today clearly are not related to or not caused by the poor diet, and they're definitely not being cured by the poor diet, as in my experience, as in the experience of many people who go on these autoimmune diets and they get stricter and stricter and stricter, restricting their body, but they're never fixing their autoimmune diseases and their reactions to the foods. They eat that thing, carnivore diet people, certain people who are big proponents of this diet, they eat one piece of any plant, anything that's not beef, salt, and water, and their hip autoimmune disease, where their hip deteriorates, explodes. You're not healed if the only thing you can eat is beef, water, and salt, in my opinion. Doesn't mean that that's not a healthy way to eat. Absolutely. It very well, I believe, is. It's highly nutritious and whatnot. However, it's not solving the problem. So, the light diet. It's pretty simple, 8 steps. I have to give credit to a mentor of mine, a teacher who put together a lot of these ideas. His name's Dr. Jack Kruse, a neurosurgeon from the United States, very good guy, and he was the one who I actually discovered. He was previously associated with the health paleo community, but due to disagreements on how these things work, is no longer part of that community. Anyhow, though, the ideas helped me a lot, and so that's why I was fascinated in them, these things about light, mitochondria, most of what I've told you today, just in a way that hopefully people can understand a bit better with the analogies and so on. So the steps I've distilled down are essentially really important. Go to sleep with the sun. This is number 1 because it allows us to rise naturally early. The other key is that in the evening, with exposure to artificial light, it disrupts these systems. If we go to sleep an hour, 2, 3 after the sun goes down, then we don't have the opportunity to be exposed to artificial light a ton, but likely we will be anyway. So another piece of this is, for example, on screen devices, using things like Iris, which is a software, or Flux, or there's some other hacks that are on YouTube, how to make your iPhone red, to reduce the blue light component of these devices, which is one of the main sources of exposure coming directly onto the retina where these receptors are, because we're looking right at the light source. Like ambient lights are also an issue, but not as much as the screen direct. So going to sleep with the sun is great because then you can wake up naturally and that's 40 minutes. So then you can wake up naturally with the sunrise, which is the next step. Rise with the sun as well. Again, this is maintaining a healthy circadian rhythm, optimal repair and regeneration, so on and so on. And when we get the morning sunrise, there's a lot of signals that come from that initial incline in light. So even in Ayurvedic traditions, they discuss that the hours before the sun comes up is what they call sort of God's time. It's time, and there was just a speaker speaking about a similar subject. This is the time when the energy is very pure. You can feel it if you're up before sunrise. It's like nothing else ever in the day, except maybe late in the evening if you're calm and not drinking or up with a bunch of bright lights. but it's very nice. And so there's the signals that come from the sunrise, lots of infrared light, the stuff that's really good for our mitochondria. We want to get this to set our circadian rhythm each day, provide us with certain signals for production of certain hormones and things throughout the day, and to get us basically charged up. So this is super important to that circadian rhythm. The next key step is sunbathing, and more generally just spending time outdoors in unfiltered full spectrum light. You don't necessarily have to be in direct sunlight, although building up exposure 5 to 10 minutes a day so that you're never getting burnt, which I have a problem with sometimes, but is the right way to do this so that you're not getting too much, but you're building up. Again, we've discussed why sun doesn't necessarily cause skin cancer. It's not black or white. If you build up your exposure safely, it's actually really, really tremendously beneficial for a huge number of reasons. But we build up what Dr. Wunsch calls a solar callus, which is like a callus on your feet from walking barefoot. From the sun, your body's more protected, and that works with the buildup of basically dead skin cells that use their DNA, which they no longer need, broken apart, which is, again, because DNA uses sunlight, it's an ultimate absorber of, or it uses UV light, pardon me, to communicate like we discussed earlier. DNA is an ultimate absorber of ultraviolet radiation, so it's the best natural sunscreen. It's just having a tan. It's really great. So living outdoors in general, if you work in an office building, it's tough, which is why generally working indoors under artificial lights is not possible, in my opinion, to achieve your maximal level of health doing that. It's definitely possible to have tremendous benefits by implementing some of these things, but not necessarily to achieve your maximal available level of health. But even in the modern world, there's so many factors today that affect us that maybe no one can achieve the maximal level of health, but we can apply these to the extent possible. So sun breaks instead of cigarette smoke breaks, which a lot of people take. You can also just go outside and not smoke. So yeah, living outdoors during the day, and then when you get enough sun, you can be in the shade. It's super, super simple. Another step, which is really important for the function of the human brain and the function of our nerves and so on, is consuming seafood. Shellfish, I like the picture of the actual fish, so I put it here. I think it says the case very well. But essentially, a lot of evidence indicates that the way that humans evolved from our ancestors was from exposure or consumption of omega-3s, particularly DHA, which are found in pretty much exclusively in seafood in really substantial quantities. They're also in meats and eggs and so on, but mostly in seafood. And DHA is used in the body to create the myelin sheathing around nerves, which allow nerves to conduct impulses, which is how we work and move and think and everything. So if you have more DHA, you can make a bigger brain, a better functioning brain. And this, for example, as you go up the food chain to smarter animals, usually they have more DHA in their brain. Just a common thread, like people say dolphins are the other smartest animal, one of them. They eat exclusively seafood. And we were the aquatic ape, as far as my understanding goes, based on the research. There's archaeological evidence of shellfish consumption as well around ancient human evolution sites, although the bones were dissolved by seawater in general, so there's lacks of links. But we were a coastal being. This is super important. And of course, the research on omega-3 supplementation is even really positive, that women with who have children, they give away their DHA to their child for its brain, and then they have postpartum depression because they're lacking DHA as one reason. So it's very important to replenish that. It's also passed across in breast milk to children. Very, very highly conserved in our bodies, not broken down like other fats for energy. Another key piece of the light diet. So the DHA, it allows us to assimilate light better, essentially. It goes into our retina more than almost any other place in the body, which is, again, converting light into photochemical or basically physical electrical energy that we use in our body. So that's kind of how DHA works. It's really cool. Water is what makes up lots of our cells. If we're drinking water full of toxins like chloride, fluoride, things that they say are good for your teeth, but the evidence is clear that that's not really the case, and there's other reasons behind it. And tap water is generally filled with all kinds of things. It doesn't have much life, like water coming out of a spring. Not optimal. Drinking bottled water or spring water, but good quality. Recycling, of course, is a benefit if you're using so much plastic. You can buy big jugs, but this is really good because we get more light in the body, but we improve the system with, for example, seafood to be able to assimilate it better. And then drinking good water. Water is essentially in our cells what holds light. And there was a speaker who was supposed to be here who couldn't make it, named Gerald Pollack, who would speak about the fourth phase of water, which is basically this special structure of water they've found, and it exists in living organisms in our cell. Water in our cells isn't like water in a glass. It's structured, highly structured, and it stores a lot of energy and charge, essentially. However, if we're drinking bad quality water, it won't have as good of an effect. So this is very, very important for our ability to store light energy and just function cleanly and optimally. People might know, does anyone know Wim Hof, the Iceman? Really, really cool dude. And he does a lot of cold exposure. That's the next step of the light diet, is being exposed to cold, essentially. So cold exposure, which is actually the way I first learned about this teacher, Dr. Jack Kruse, was his writings that were put across the paleo community about cold thermogenesis, which essentially means go into cold water, cold expose yourself, and your mitochondria, again, this researcher, Dr. Wallace, from earlier on, the groundbreaking researcher on mitochondria, he explained to me, because I was curious, how does this work? Cold exposure activates nerves on the skin, receptors that talk to the brain, that basically says back, start increasing the activity of these proteins called uncoupling proteins. So instead of, remember back all the way to that mitochondria, no way I can get all the way back to that right now, but there's that gradient, and so there's that one ATPase that we let, just like the revolving door, that we let those energized protons pass down through as they want to go down the gradient. With these uncoupling proteins that we activate when we're exposed to cold, it allows those protons to pass through a different channel, but instead of diffusing or using that energy to create the potential energy to create kinetic useful energy in the body, or ATP, they generate heat, just dissipates the energy as heat. So we massively upregulate our mitochondrial energy generation, which basically, first of all, if you go in cold water, you feel like, whoa, because your engine just got turned on, like full on. So it's super cool, and that infrared light that the mitochondria then generate themselves in large amounts is beneficial based on the research of Dr. Pollack, who's into the water. This infrared light can structure this water and allow it to basically improve the structure of the mitochondria because the water is more structured. So this is sort of some level of speculation, but the evidence lines up to where it's very, very plausible. And again, just go in a cold bath, you'll feel great. Also, naturally, when we're by the seaside, we go into cool water, cool our skin, absorb more light. Again, doesn't mean you should do that ad infinitum until the end when you're absolutely saturated with too much light. You don't want to do that. But a little bit can be really nice. And even the researchers doing, or the people doing heliotherapy, found higher or better effects oftentimes when they would put their patients in the seawater in England on the coast. Just dipping them in the water, keeping them in the water, and then having them in the sun, they would find even better effects. So cold exposure, huge. And just with this one piece of the light diet, Wim Hof is able to cure all kinds of diseases, this and his breathing techniques. Autoimmune diseases, they're improving, it's tremendous. So imagine if you do all of it. So they're all based on the same principles, by the way. It's the mitochondria function being improved, generally speaking. The next step is avoid exposure to man-made electromagnetic radiation. So this includes artificial light, but it also extends to the invisible portions of the light spectrum, which include things like what we use to communicate today. So Wi-Fi, Bluetooth, cell phones. Basically, these affect these things in our cells. There's an expert here on the subject from the UK, but basically they affect these things in our cells called the voltage-gated calcium channels, which control the movement of calcium in our cells and basically create massive problems. The research is thoroughly extensive. We don't have time to get into it, but just so you know, the research done by the cellular industry in the United States, which is one of the biggest lobbies in Congress, giving money to congressmen, shows virtually no effect in general. But the research done by independent researchers since the 60s, 70s, and 80s, which has been sort of ignored to some extent, shows majority there is an effect from these non-native electromagnetic fields, meaning radio frequencies, microwave frequencies, frequencies emitted, static, electric, and magnetic fields emitted by our devices. These all affect us as an electromagnetic being tremendously. There's lots of people who are actually hypersensitive to this, and it makes them feel pain from being exposed to these fields. So there's a real issue here. We don't all necessarily feel the effects, but it's affecting our cells at a deep level. And that is 6, I believe, and the last and 7th step of the light diet, which I was looking for a long time because I've been sort of putting this together for the last, I started this when I was 14, was when I first dug in. I'm 20 now, so it's been the last 3-4 years I've been trying to put this in a way that I could explain it, and I think I've done just that today. But the last step that was looking for a long time, how to phrase it, it's to cultivate your inner light. So in other words, you're going to take this light in, you're going to do stuff with it, but if you don't cultivate it and create a person that you'd want to be with that light, then you're not necessarily going to enjoy any of it. So things I do for this, like Qigong, meditation, Also, I think things like reading good books, doing things you love, developing your hobbies, developing your passions, being kind to yourself, having good friends, and especially removing people who suck energy from you, because biophysically, they actually steal your light. People who are like those friends who just kill you and make you feel down when you're with them, they're stealing your light. People who are, and this is some level speculation, but based on the evidence, I think it's very, very possible. People who give you lots of light, they radiate, they glow, you just see them and you're just shining, or someone you're attracted to, they're contributing light to you, essentially. Anyhow, so yeah, one final piece to end on, which is very fascinating to me, more than almost anything, is that there was research done that showed, it's in a textbook called Light and Shaping Life, Biophotons in Biology and Medicine, which is where I learned about the other guy, Gurwitch, who researched the fingertips and so on. Essentially, was that when a cell is dead or an organism dies, they were able to measure that the organism was emitting this extreme low frequency ultraviolet light for quite a period of time before rigor mortis, when the organism is cold, hard, and dead. So essentially, thinking about it, our body is a being of light, and when we die, the light actually leaves the body. It's similar to, for example, the soul leaving the body, like is discussed in religious traditions and so on. But there's actually research that implies that this isn't crazy, and there's actually something to it. So what that implies is that we aren't, and people say this as a cliche, but I'm telling you now sort of the science behind why it's actually true. And Luke Story actually gave a talk I just saw on the monitor when I was looking at it. It was about you don't have a soul, you are a soul. So the soul being the UV light component that makes up the body. When we die, if I were dead, for example, you would maybe point at my body and say, that's Matt's body, but you wouldn't say that's Matt. Matt's gone. So what was Matt? Where did he go? Very likely, I think that we are the light that makes us up, the soul, you could say, and when we die, that leaves us, and so, yeah, so that's why I say cultivate your inner light, because that's like cultivating your being and who you are. And with that, that's the Light Diet. I hope you've enjoyed it, and I hope you learned a lot. Thank you.